knowledge with calculus to do this one totally algebraically. So it's actually a really good one to do by table values, absolutely. Hold on a sec. Hello? What is the function? The function is 2 to whatever you put into it, right? So you end up with this right here. That right there. That right there. So it's as h goes to what? It's as h goes to what?
0.
H goes to 0. Do you see it right there? It's h goes to 0. So when you make your table of values, you're plugging smaller and smaller values into this. You're plugging smaller and smaller values into that. As h goes to 0, you get closer and closer to 2. As h goes to 0, you get closer and closer to 2. Do you remember when we first did our estimates for average rate of change, we did it like 0 to 2 seconds and then 2 seconds to 4 seconds? And then to get a better estimate, we zoomed in further. We did 1.5 seconds to 2 seconds and 2 seconds to 2.5 seconds. Over here, we're zooming in real far. If you can choose what values to do, choose really small values. Why are these negative and why are these positive?
That's both, you're right.
Well, we're approaching 2, right? The h value represents the distance from 2. So when it's negative, it means you are to the what? To the left. And when it's positive, it means you are to the right. So you plug in smaller and smaller values using the table view or that evaluate feature like y bars on your calculator. And you plug it in and look what happens. Do they get closer and closer to something here? It looks like they're approaching 2.77. It looks like it's approaching 2.77. That's what it looks like. So what's going on is this point moves closer and closer, and as that point moves closer and closer, as this point moves closer and closer, this slope gets closer and closer to the slope of the tangent line. So what they're doing is you do that on, if this is to the left, what does the h value? Where is the h value here? If this right here is 2, this distance right here, this right here is the h value right there. The distance from the point you're at to 2. So since that's to the left, what is that h value going to be? H is less than 0 here, right? But if you did a point coming the other direction, what's this distance right there? H is greater than 0. So what you're doing is you're making it infinite, well, as small as you want on both sides. And what does this table show over here? It shows that it looks like it's going to 2.77 in both cases. About that. Now it's not exact, but it's really close. Let's see if we could do this one algebraically. Let's see if we could. What's the function? You remember what it is? 2 to the what? 2 to the what? 2 to the x? I would love to have a conversation with someone other than Calvin. You're very nice to have a conversation with, but I'd love to hear other people. So you take these values and you plug it in. What's f of 2 plus h? That's going to be 2 to the what? 2 plus h minus, what's 2 to the 2? 4 all over h, right? You're doing this. You need to remember your exponent rules at this point. What's 2 to the a times 2 to the b? What is that?
2 to the a
plus b. You add them, and it can go in both directions. So what can you do to up here? What does the top become? 2 to the 2 times 2 to the h minus 4, right? All over h. What is 2 squared? So what can you factor out of both terms on the top? So you have 4 times 2 to the h minus what? 1 all over h. The challenge you have at this case right here, the challenge you have right here is what would you love to be able to do? What's your whole purpose in this algebra? What's the one thing you're trying to be able to do? Factor h out of the numerator so that what you can do what? So you can cancel the h, right? You want to cancel out the h in the denominator. The challenge here is, do you have any algebraic maneuver that you know of to get that h out of there? No, you don't. You're stuck at this point. So that's why at the moment, the only way you guys can come up with a derivative at this point, which is the instantaneous rate of change, see this right? That's the derivative, is by table values, because you don't have the algebra to do it otherwise. You have to be very, very careful. Absolutely, the key here is being very careful when you go from this right here to this right here. So how do you do that? You do it piece by piece. First you do 4 plus h times 4 plus h. What's that going to be? 16 plus 8h plus h squared. And then you multiply it by 4 plus h, another one because it's cubed. And what are you going to get? You're going to get that yellow right there. You're going to get that. So once you get that, what cancels? What happens to the 64s? Which is great because you're left with things with just h's in them. So you can factor out an h from each of these right here. You can factor out an h from each of them. And once you get an h out from each of them, what can you do? Factor it out, nuke it, h goes to 0. So what happens to these two terms? H goes to 0. So what happens to these two? We need to adjust. We need to adjust that. Be very careful on the algebra. There's no way to avoid some algebra. This is a calculus class, so it's going to be mainly calculus, but you will see it. It will happen. Every class you take, there's going to be some reliance on, not everyone, but many, it's going to be very frequent that algebra is going to come up like this. You do have a test Saturday. You do. Okay, so let's do this in your head. Well, when you do this graph, you go to -2, and it's going to go up like this, right? That's a really poorly drawn graph, but it has the important point here. The important thing is, to the right of 0, what are all the tangent lines going to be on this side? Their slopes will be positive, but on the other side, they're going to be negative. Any tangent line here, positive slope. Any tangent line here, negative slope. So we're looking for a positive slope. How do we evaluate f prime of 2? We use the limit definition. We use the limit definition, and what I would love you to do every single time is literally write down limit as h goes to 0 of what? A plus h minus f of all over h. Write that down and start there. What is the a value in this case? What's the a value in this case? 2. In this case, a is equal to 2, and what does f of x equal? It's right there on the board. No. What is f of x? It's literally right there. There you go. The first thing I always check when people ask me for help on questions is, did you like copy down the right thing? Literally write those things down, and now you can fill in the blanks. Now you can fill in the blanks. So what is this going to be? The limit as h goes to 0 of, well, you're plugging it's f of 2 plus h minus f of 2 all over h. That's the limit as h goes to 0. Now we use the function. Where do we plug in 2 plus h? Where do we plug that in? Into the x of the function, yep. So it's 2 plus h squared minus 2. And what do we subtract from that? What do we subtract from that? 2 squared minus 2, right? Over h. Finish this for me and see if you can get an answer. That thing I'd like you to write down? Limit as of a plus h minus all over h. I like this. You can put the brackets around it. That's great. And then in this case, what does a equal? -2. In this case, f of x, it's already written there, is 1 over x. So let's write this out and see what it comes out to be. Well, actually, you do it first. Try it algebraically by yourself first. It's now the limit as h goes to 0 of what? 1 over what? 2 times h minus 2. Can you now plug in 0 for h? So what's that answer going to be? -1/4. Correct. This is a bunch of algebra that you have to be able to do. You have to be able to do. Have to be able to do.
If you were to multiply by h, wouldn't it have to be?
So in the first quadrant, you have something like this, right? And then in the third quadrant, what do you have? This, right? Where does x equal -2? Well, maybe like right about here. There's x equals -2. So if we go to that point, if we go down to this point right here, what's the slope of that line going to be? What did we just show this slope is? -1/4. Should it be negative? Yeah, it should. I have a question for you. What do you think the slope is at x equals 2? Careful. What do we think it is? -1/4. It's actually the same. It's kind of cool. Kind of neat, huh? Because you could have tangent lines on both sides, right? It's kind of neat. Okay, so I have a question for you. How do you write the equation of a line? What do you need to write the equation of a line? What do you need to write the equation of a line? Yeah. Slope and a? Or better yet, a slope and a? Does it have to be the y-intercept? So slope and point. This is what I want you to focus on. To write the equation of a line, you need a slope and a point. So write the equation of the line that is tangent to f of x at x equals -2. Do we have the slope, Connor? Yes. What's the slope? We just figured it out. No. That's where we're finding it. What is the slope? We just did the work right now. What is the slope? Yes, negative 1 over 4. So the slope in this case is negative 1 over 4. We need the point. We need any point. Well, we know the x value. We have to use that point. It's saying at x equals negative 2. So negative 2, but we need the y value. How do we find the y value? Plug it into the function. What is the function? 1 over x. So what's the y value? Negative 1/2. We now have all the information you need to write the equation of a line because all of you remember what the point slope form is for the equation of a line. What is the point slope form for the equation of a line? Jen? Y minus y1 equals m times
x minus x1.
yes. So in this case, where do we put the m? Well, what is m? It's right there. So can we plug all these things in? Here's x1 right there. And then do we have y1 as well? We have y1 right there. So what's the equation going to be, Leanna? Just read it off to me. Y minus
Negative 1.
yes equals
Negative 1/4.
times x minus
Negative 2.
-2. The only thing I want you to do not write this in slope-intercept form. I could care less about slope-intercept form unless I tell you to write it in slope-intercept form. But do I like double negatives?
No.
So you write y plus 1/2 equals negative 1/4 times x plus 2. Stop there. I know you guys have this unbelievably huge crush on slope-intercept form. Break up with it, okay? It's a damaging, painful relationship that you need to abandon right now. Stop there. That right there is a line, and it goes through x equals negative 2 on the function, and it's tangent. Stop there. Why do I so vehemently want you to stop there unless I ask you to go further? Yeah.
Because we have our answer.
You have your answer, yes, but why else? It's much easier. It's really easy to see if you did it right at this point. And also, if I gave 100 kids, if I asked 100 calculus students, put this in the slope-intercept form, what's going to happen 5% of the time? Something's going to happen, yeah. Don't do extra work. What's really interesting, for example, like on the AP exam, if you do a bunch of, like, if you have the right answer but then you keep going, you will lose points because they look at everything, right? If you made a mistake, you made a mistake. You have to be really careful about that. You're not taking the AP exam, but I want you to really get this into your head that later, if you take more calculus, which I hope many of you do, stop at slope-intercept form. Stop at point slope form. Stop here, stop here, stop here. So let's change this a little bit. Let's say I asked you, what's the equation of the tangent line at x equals 4? Find that for me. 1/4. So we have the point. That's the point. So all we need now is to do the slope, we would do the same exact work we did up here, but instead of negative 2, you see all the negative 2's we have? What's the only thing that changes? That becomes a 4. So does the math change? Yes. Is the process identical? Yes, it is. The process is identical. So it's really fair of me to be able to, I think it's fair. It's going to take some work for you to get good at it. I could say, what's the equation of the tangent line at x equals 10? At x equals negative 1/2. It's the same type of work. What do you need to write the equation of a line? A point and a slope. Does it have to be the intercept? Nope. Does it have to be written in slope-intercept form to end this? Nope, it does not.